All right, this is the start of our week 2 video assignment. This is going to be broken into 2 different videos for the rest of the weeks in our semester. So this is the day 1 video over all of the 2A module information that I thought would be good to do in a pre-video. So 2A1 per capita, that just means per person. Let's look at this first example here. It says, our last shopping trip allowed the group to eat 360 gummy candies for 12 people included on the trip. Find the number of gummy candies per capita or per person. So number of gummy candy over number of people. We had 360 eaten over 12 people that we had on our trip. That reduces down, we divided on our calculator to 30 gummy candy per person or 30 gummy candies per capita. All right, so let's do one together. This says there are 175,000 registered German Shepherd dogs, which we're just going to abbreviate as GSD, in a country with 13.2 million people. Find the number of registered GSD per capita. So notice that's telling us how we're going to be setting this up. Round our answer to 5 decimal places. So we're going to have our registered German Shepherd dogs, 175,000 on top. German Shepherd dogs. Over the number of people, so that's 13.2 million, and we're going to remember write our million as the 10 to the 6th. Okay, and then we're going to type that in on our calculator to see what we get. I will caution you, make sure when you type this into your calculator, you type the whole denominator in a parentheses. Otherwise, your calculator will only divide by the first number in the denominator if it's not already got a fractional kind of button. So we're dividing by 13.2, notice in a parentheses, times 10 to the 6th. Close my parentheses for my denominator. And I'm going to write this out to 5 decimal places. So 0.0132, 5 is in the 5th place. So we look at the 7 behind it and that will bump it up. So this would round to 0.01326 German Shepherd dogs per capita or per person. Sometimes saying per person makes more sense to our brains. So this is what we would enter into our new module. But if you were thinking about like talking about this with a neighbor and you're like, whoa, did you know there's this many German Shepherds per person? You don't even have a full dog here. So sometimes we would in an everyday like situation, not just for Newton and answering it in how they wanted it. I would want to scale this up so I could actually talk about at least a single dog. So one way you can scale up is just by kind of thinking about what we did with scientific notation. We multiplied by powers of 10 or divided by powers of 10. If I multiply by powers of 10, I can make this larger. But if I do that, this per one person will also get multiplied by a power of 10. So this is just for scale, for realisticness, not your final answer. So not what Newton would want. They want the answer we just came up with. But if we wanted to talk to our neighbor about these dogs, I would probably, let's see, multiply by 10, and that would give me 0.1326, because you move your decimal 1 place to the right when you multiply by 10, German Shepherd dogs per 10 people, because you'd multiply 1 by 10. So that's, again, not even a full dog. If I multiply by another 10, I would move the decimal 1 more place to the right and get 1.326 German Shepherd dogs per, multiply this by 10 again as well, 100 people. So that makes a little more sense in terms of like realism. We'd want to give Newton, obviously, the answer that they're looking for. Did we find the registered German Shepherd dogs per capita? But if you're going out in the real world, you're not going to say, I have 0.01 dogs per person, probably. You'd want to give that to people in a way that's more visual in their brains, that they can say, oh, about 1 dog, roughly, because we would think this would not round up, 1 dog per every 100 people. So that is just a little bit more realistic if we're going to discuss it. So let's look at this next one. It says a town has 33 schools and a population of 102,000. What is the number of schools per capita in this town? So we're going to be doing 33 schools divided by 102,000 people. Where the per capita is per person. So I'll take my calculator and we'll divide that. So 33 divided by 102,000. And notice my calculator is giving me this weird little symbol at the end, this e to the negative 4. Essentially, the calculator is giving it to me in scientific notation. This is how my calculator represents that, with that little e to the negative 4 at the end. So I'm going to write that down to like 5 or 6 decimal places, and then we're going to adjust it to get it in the right form. 9. Yours may not have done this, but my calculator did when it saw all of those digits. So that keeps going. And then it was times a 10 to the negative 4 at the end. So I'm going to move my decimal 4 places to the left to turn this back into standard form. So I need to add in those zeros. So to round this to 5 decimal places, I need to go from my correct notation, no longer in scientific. So I'm in standard form, and we're going to have 0.00032. And that would be schools per person. And that's going to be what they want in Newton. They're going to want you to give them the answer you got directly when you did the division. But again, scale for realism, because I'm more about realistic math if I'm going to do something, especially when I'm going to be giving people data. So Newton would want this. If I was discussing this with my neighbors or my family, I would be like, well, I'm not going to say I have 0.00032 schools per person, because that's per one person. I could multiply by 10. That would only move my decimal 1 place. Schools per 10 people. That's still not quite realistic enough. Multiply by another 10, your decimal will move 1 more place to the right. Oops, that's not a 5. I should probably write schools as a SCH instead of, just wanted to abbreviate it. Per 100 people, because we've multiplied by another 10. I could go another decimal place, 0.32 schools per, now this would be 1,000 people. And I really at least want to have a school, so I'm going to move it 1 more place by multiplying by 10 1 more time. So I get 3.2 schools per 10,000 people. And again, that would be the statistic that, or the data that I would want to present to someone. If I'm saying, okay, what's the concentration in a way that people in the community would understand? Yes, this is technically correct. This is per 1 person, but scaling wise, this would make more sense in my brain. I would think, okay, if I have a room full of 10,000 people, I can take those people and distribute their children at about 3 school districts. Okay, so that's a little bit more realistic for our brains. But again, go with the answer Newton wants for your homework, okay, and for our exams. So at a recent Major League Baseball game, 56,732 hot dogs were served on $1 hot dog night. If there was 41,531 people in attendance, what was the number of hot dogs per person? Okay, so we had 56,732 hot dogs, and we had 41,531 people in attendance. We're going to round to 2 decimal places if needed. So 56,732. By the way, that just, or if necessary, that just means if it goes beyond 2 decimal places, the answer does, we'll round to 2 decimal places. That's the if necessary part. So 56,732 divided by 41,531. I'm going to get 1.37 because that 6 will bump up because of the 6 behind it. So roughly 1.37 hot dogs per person. Now, or per capita. Did every single person have a hot dog? Probably not. This is more like an average, okay? And most people didn't eat like a whole hot dog and a couple bites of another hot dog. Again, it's averaging it out, okay? And then we're going to look at the next little topic, which is use proportions to scale values. So we already kind of talked about this a little bit, but this is using proportions to do it. So these types of problems are, they'll give you an actual value and usually a population. And they'll say, well, what amount of that item would be out of just 100,000 people or 10,000 people? So if you look at this one, it says Indiana averages 82,650 births. That would be total Indiana average births each year to a population of 6,745,360. So that's our total Indiana population. We want to know how many of those births were would be broken down if we scaled to just 100,000 people in Indiana. So notice I've got my number of actual births, total births for the state, total population, and I want to know how many births are going to be attributed to 100,000 people in the state. So if we go ahead and cross multiply that, so 82650 times 100,000. Always do the diagonal with both numbers known first. Then we're going to divide, because this would be equal to this times this. So we divide by the 6,745,360 to solve for x. And we're going to round this to the nearest whole. So 1,225, because the 2 would not bump it up. So x is approximately 1,225 births in Indiana per 100,000 people. And again, Newton usually doesn't ask for the units, but they will ask for the numerical part. Number 4, there are 352 ice cream shops in a city that has a population of 752,500. How many ice cream shops are there per 100,000 people? So again, total ice cream shops over the total population equals the number of ice cream shops that we're looking for over just 100,000 people. Okay, so 354 over 752,500 equals x over 100,000. Go ahead and cross multiply the diagonal where we have the two numbers. So 354 times 100,000. And then divide that by the value that was connected to x when we cross multiply, 752,500. And we're going to round. Oh, we didn't give you rounding directions for this one, so let me write them. So round to the whole. So that would be 47 ice cream shops per 100,000 people. Okay. Let's look at our, I think this is we're getting close. There's 2 pages left for the day 1 video. So we have, this is combined. I will be covering a lot of this in class as well. We'll spend a lot of time on proportions and equations to solve percent problems. This should have said proportions / equations, just because those are both included in those 2 sections. We're not actually going to use either of those in the pre-video information. We're just going to talk through some general common sense ways that people usually solve percent problems, and then we'll have some more formal methods in class. So percent is per 100. How to determine a percent given a part, which is a value you're considering, and the whole, which is your base or comparative value, is we do the part divided by the whole times 100%, because this will give us a decimal and we change it to a percent. We will not always have the smaller number divided by the larger number. It depends on what you have. So I'll show you an example of both ways. One where the bottom is the larger value and one where the bottom is actually the smaller value. So the first example says you score 88 out of 150 points on an exam. What percent did you score? Round to the nearest 10th of a percent. Notice this is very important. 10th of a percent means you have your percent and you round 1 decimal place after the decimal with the percent symbol on there. So you don't round before you go to percent form. You round after you're in percent form. Okay, so after you've multiplied by the 100. So the whole is the total points on the exam, which was 150. The part is what you scored, which is 88. So 88 out of 150 times 100%. Notice I did not round this. I've put my ... This is a repeating decimal. Times it by my 100%. I've got plenty of decimal places still to look at this. To round to the nearest 10th of a percent, I check the 10th place once I'm in percent form, and the digit behind it would bump that up. So this is 58.7%. Notice my number 5. A test is scored out of 50 points, but you earned 55 points. So you actually earned more points than the test had. You got some bonus points. So So what percent did you earn on the exam? So this, notice the numerator is bigger because we earned more points than actually the test was scored out of. So 55 divided by 50 is 1.1. It does not repeat. It's a terminating decimal times 100%. This is going to equal 110%. So you scored 110% on that exam. Now let's look at some ways that we can determine what value is a specific percentage of a base, so of the whole. So if we're looking for the percent of the whole, we can do the following things. Change the percent to decimal form. You can either divide by 100 or move the decimal 2 places to the left if you have your percentage. Multiply by the base and round as directed if needed. So find 43% of 89. Round it to the nearest tenth if needed. Change 43% to decimal form, so divide by 100 or move your decimal 2 places to the left from the 43%. Multiply the base or the whole part by your percentage as a decimal, so 0.43 times 89 is 38.27. They asked us to round to the nearest tenth, so I got that that is 38.3. So I said, and I put in about because we did round here. So therefore, 38.3 is about 43% of 89. This is the part. It is this percentage of the whole. Okay. So let's do one or two together. So find 40%, or excuse me, 44% of 94. Notice the of is a key giveaway that this is going to be the whole, this number right here. Okay. So 4% as a decimal, we'd move our decimal 2 places to the left. So that is 0.04 times the 94. So let's do our calculator for that. 0.04 times 94 is 3.76. I'm going to go ahead and write that out. The directions, say round to the nearest tenth. I need to write the right number first. So that means we're going to look at the 7 because that's in the tenths place. The 6 behind it is a big 5 or bigger, so it's going to get to round to 3.8. So 3.8 is roughly 4% of 94. For this one, to change this to decimal form, you get 1.17. So 1.17 times 43, the whole. And let's see what we get when we work that one out. 1.17 times 43. That's 50.31 exactly, but we want to round to the nearest tenth. So that's going to be 50.3. So 50.3 is about 117% of 43. And that makes sense because it's more than 100%. This number is bigger than our whole. So we're getting more than 100%. And then lastly, on this part for the video 1, we're going to be talking about how do you find the base or whole given the percentage and the part. So you can change your percent to decimal form, divide by 100, or move it 2 places to the left, just like we did in the previous ones. Divide the part by the percentage in decimal form, round as directed if needed. So like I said, a lot of people struggle with this one specifically because it's just backwards to what our brains want to do. And this is why we're going to have very specific methods that we're going to go over in class. So 89 is, this is a keyword that we have the part. This is a percentage of what number? Round to the nearest tenth if needed. So we're going to follow the directions kind of that were bulleted here. Change 43% to a decimal, so that's 0.43. Divide the part by the decimal form. So 89 divided by 0.43 is going to be this 206.976744, and it kept going. Round to the nearest tenth. So I looked here. The 7 behind it bumps it up, but that would make it a 10. So we have to push that carried over 1 into this next position. So that would be 207.0. So therefore, we can restate this now. We can say 89 is about 43% of 207. All right, last one for our video 1. This says 8.5% of what number is, so notice that's the part here, 127.5. So we do first turn this into a decimal, move it 2 places to the left, or divide by 100 if you prefer that. We're going to then take our part and divide it by our decimal of the percent. Okay, decimal form of our percent. And that's going to give us the estimate for our whole. Okay. So 127.5 divided by 0.085. Let's see what that comes out to. We may or may not have to round it, depending on what the numbers are. It's not needing rounding at all. It's a whole number. So it's, and so since we don't need a round, we can keep the equal sign. So 1,500. So if we restate that, let's see what it says. 8.5% of 1,500 is 127.5. Okay, so that does make sense. Now, like I said, this part is kind of just an introduction and what a lot of people have seen in, previous just everyday uses with percentages. We will have a very, very, very specific proportion method and equation method that you can plug into every single time to help you solve these and not try to remember when do you multiply, when do you divide. So this is just kind of, like I said, the common sense, more or less what everybody kind of has seen in the past, or they've, seen people do the math that way when they're working with percentages, like at a shopping store. But we want to be able to like have a very set of steps that we can do every single time, and that will stay consistent. So that'll be in our class session. So hopefully you enjoyed video 1, and I will see you soon.